Thanks everybody for coming. My name is Gregg Ganley. I'm a mobile security researcher at MITRE, principal investigator working on iMAS, iOS mobile application security. So just to give you a quick background about what is MITRE, we're a nonprofit company. We work in the public interest. We don't manufacture products, essentially enabling us to provide conflict-free guidance. We operate several FFRDCs, what are called federally funded research development centers for the DoD, the FAA, the IRS, various organizations. Inside MITRE, we have an independent research and development program, and essentially we're doing look-ahead research for our sponsors, and iMAS comes under this. We're in the second year of our research with iMAS. So real quick, if I were to get on a quick elevator ride with you, I would say that iMAS is iOS application defense, and then expanding that a little bit, we're a secure, open source application framework to reduce application vulnerabilities and information loss. So let me give you a little bit of background on iOS security. In general, you could say that it has 4 layers: the device, data, network, and application layers. Inside of iOS security, the security of iOS itself, they've actually done a really good job over the years. It has gotten better. But just looking at the OS itself, they actually have they've reduced the attack surface as much as possible by not having Java or Flash. They've stripped down a lot of their system apps as compared to those same apps running on full-blown Mac OS X. There's a smaller footprint in that if one did get root access to the device, there's no shell, there's no commands in the shell to manipulate. Unlike Android, when you get into when you root an Android device, you have all that at your fingertips. There's also various, they have the code signing, basically pages in memory and all that stuff. So they do a lot to make the security much more enhanced right out of the box. Their model definitely is comprehensive, and it has evolved. Recently, iOS 6 was granted FIPS 140-2 compliance, approved government use. This means that more and more government agencies are likely going to be building custom apps now that they have this FIPS approval, because that's one of the wickets they need to get through in order to field these, which also means there's more need for iOS application security, and in particular iMAS. So just to scope where our research is coming from, the iOS attack surface is multifaceted. The threat vectors can be anything from a lost, stolen device where one can have physical access, and then there's malware that can be inserted, perhaps by the browser JavaScript engine. And then more recently, we're seeing enterprise apps as a vector, and that's because essentially developers who are building iOS apps for enterprise are sometimes grabbing code off the web from the open source community. Some of it is not well vetted and perhaps has some malware inside, so that's another way for malware to get onto these devices. And if you look at an attacker's purpose, they're looking to steal application data, find enterprise credentials, eavesdrop on the video, microphone, and phone calls. And then the other scariest one is the command and control recon to kind of get back into the enterprise network, essentially use it as a foothold to get back into your enterprise. So for iMAS, we're focusing on the application use and its data as the target, and that's enterprise data, tactical operational data. If the military were to field these and field these devices, give them to soldiers, we want to try to protect that data. And finally, patient health information is another aspect that we're looking to help lock down. And we want to try to protect against malware and physical access attacks. And really, that's securing with static and then dynamic application controls is the focus of iMAS. So if you look at hacking and jailbreaking in iOS, the attacks are well documented. John Jartsky's book on the left from O'Reilly, and then Dino Disovi, Miller, and a bunch of other folks there. There's a bunch of well documented ways to get into iOS and then into applications. The talk right before me was a great talk that went into the specifics of how easy it is to reverse it and then do your method swizzling and all that. There are jailbreaks. Haven't heard of jailbreaks for iOS 7 just yet, that is untethered ones. But in iOS 6, when that came out, there was really prominent ones, evasion. And then, once the device is jailbroken, Dino Daisovi put this slide up back a couple of years ago at Black Hat, where essentially if you have a 4-digit passcode and it's numeric, one can put a brute force program on the iOS jailbroken device, run it real quickly, and within, at max, on an iPhone 4, he found that it took 18 minutes to crack a passcode. And it gets longer and longer as your passcodes get more complex. But with a large majority of folks not having passcodes, and even if they do, they're only 4 digits, it's a real simple way to get around there. Of course, once you have the passcode, you now have the key to unlock the device, unlock data protection on the device, which now gives access to the data around these applications. So, kind of summarizing that together, if you look at a standard iOS app today, there's vulnerabilities, that being the 4-digit passcode, I just talked about that. And then you look at the various system components. Kind of once you're in, one can, if a device is jailbroken, you can then have root access. The memory itself, the debugger is a way to get a hold of your device, and then your application itself. And then, of course, user authentication and application access. If you don't build this into your app, you're using the OS, which really there's not much available for you to do that. So that's an area where one could expand on. And then finally, the keychain and flash data storage. Again, so once you have this passcode, you can access the keychain and you can access the flash data storage. So there's kind of the vulnerabilities are somewhat numerous. And so here's what we're trying to do with the iMAS Secure Application Framework. There's a lot on this slide, but essentially we're looking at providing somewhat of an application container. It's not a build-on-the-fly, single library kind of thing. It's a series of individual security controls that developers can download and use from GitHub, because we've open sourced. So we're basically taking these security controls beyond Apple iOS. We're trying to reduce that iOS app attack surface. And these are vetted, prioritized security controls, and I'll talk about that. And like I said, it's open source, and we're trying to grow that open source community. So the takeaway here is that we have a whole bunch of different controls that I'm going to talk about. And as this research year goes on, we're going to keep adding into more of those controls that I'll talk about. And these are the various security areas. So if you look at where iMAS sits in the application stack, this graphic was taken right out of the security document that was published by Apple. And if you look, essentially, the stack in Apple is fairly closed off. Unlike Android, there's many different ways that you can kind of hook in and add your security or add to or embellish your security. With iOS, you pretty much, the area has to be within the application level, and that's where we fit right up in the app sandbox. A few years ago, MITRE put together a report for the Department of Defense CIO, and it basically went into describing all the various mobile threats that are out there. So MITRE did a pretty good job of categorizing the various mobile threats. They're software-based, they're web-based, network-based, there's physical-based threats, enterprise, and of course user-based. If you look at all of these, iMAS is applicable to about half of these, 12 or so. Which is pretty good. I mean, there's some that are network-based, and we're focusing on the application itself. Speaking of OWASP, the OWASP Mobile Top 10, we cover 6 of these of the Mobile Top 10: insecure data storage, poor authorization and authentication, broken cryptography, security decisions, and then sensitive information disclosure. So we're trying to cover as many of those as possible as well. If you look at iMAS and what we're trying to do, we have a graph here that talks about the number of security controls on the left. So my claim is that the more security controls you add to your application, the more secure your app becomes. And the spectrum can go from consumer to enterprise to what I'm calling Enterprise Plus, and then you can get into the classified space. So the yellow box is kind of where we're at with iOS 6 today. That first black dot there, and then if you add a mobile device management system or a manager, and then you add perhaps an app container. We heard those in the last talk, but there's Good, there's Mocana, there's a couple out there. You're going to add additional security controls that are going to bring you closer and closer. But as the last talk just talked about, there are a lot of ways to get around these app containers, and so I'm saying if you want to make, essentially increase the security of your application, take a look at iMAS and take a look at the controls we have, and by adding them to your app, we're going to raise it up to the point that you could get closest to this enterprise plus level and have a much higher level of assurance. We haven't looked at iOS 7 just yet. If folks have developed an iOS before out there, iOS 7 itself, there's a lot you have to do to change over your tool sets, up-rev your OS, etc. So we're going to get there, but we haven't got there just yet. How many iOS developers are here today? Oh, great. So let's take a look at the security controls. Just kind of bouncing around, starting in the top left, the device access. So I talked about the 4-digit passcode. We have a security control called passcode check. And I'll talk about that in a moment, but essentially allows a developer to to confirm that there is a 4-digit passcode or even a complex passcode on the device. Application access, iOS doesn't provide any way to essentially put a password, so you often have to build it yourself. This is a control where a developer could quickly add an app password to the app. Data at rest, the keychain and core data are vulnerable areas. And so we have a control called encrypted core data, secure foundation, which is essentially an OpenSSL port onto iOS. And we're also looking at MDM remote control. Runtime, the RAM and debugger, jailbreak root access. We have a security check control one could add that gets into jailbreaking and debugger attachment detection. We have a memory security control, and then we're researching encrypted RAM disk this year. App tampering, we have this notion of forced inlining. So as folks know, inlining functions is a good thing, and so we have a security control that talks about that as well. And then several others we're doing research. In terms of data in transit, that's somewhat out of scope. That is out of scope for iMAS. But I looked around and actually found a great GitHub repository, SSL Conservatory. These folks have a really nice kind of tutorial way to do SSL cert pinning. And that's at least one step closer to having a more secure network connection. So just talking about each one in particular, so starting with the passcode check, this is a programmatic library and a method to enforce device code passcode use. Essentially on iOS, there isn't a library that a developer could call that says, has the user set their passcode, and if so, is it a 4-digit, 10-digit, is it complex? Because you'd like to be able to have your app change its behavior based on that decision. So anyways, we provide this, it's a tutorial. It's also a security control that one can compile in and follow along. The research there took a little while to kind of piece it all together, what was out there, but it's actually pretty interesting. The app password itself, we have a secure, simple, user resettable password to protect. And essentially, if you go out and look for app passwords up on GitHub or other open source areas, there are some out there, but if you look in the background, they're mostly a user interface, because in the back they usually just go to a class method that they're setting the password, and they kind of leave the whole storage of the password up to the developer. We actually get into the behind the scenes where we're encrypting it properly and not storing it on the device. And we're using OpenSSL. We're not using data protection or the iOS keychain. So that's a great one to look at. Encrypted core data is one where if you look at core data today, if you can actually select that you'd like the data to be stored in a flat file, or you'd like it to be stored in a database. That database is SQLite. The SQLite library that's compiled into core data just stores it in plain text. So if one has the passcode, gets into the device, they can find these SQLite files and easily pull them back to their laptops and peruse and look through all the data. So what we've done is we've actually created our own core data API that's similar to core data, and we've compiled in SQL Cipher, which is an open source way to compile, or a shim that goes above SQLite. And so that particular control is getting a lot of traction out on GitHub, and it's one that people find somewhat easy to use, and we're starting to get more of the community to develop. Security check is a simple way to do jailbreak and debugger detection, and we have a lot of anti-forensic techniques in there using C macros. nameless function blocks, inline methods. That's something that folks find useful. Secure Foundation, where we've taken OpenSSL crypto and we bundled that, made it easier for developers to grab and make use of. We've also grabbed the FIPS version of it and compiled that. So a lot of this is the use case is the security requirements come in on your application, and the developer is asked to do these, meet these requirements. The developer is somewhat left to figure this out and develop on the fly. Here, we're hoping they can kind of come to our site, come to GitHub, take a look at the particular controls, and see how these controls are done, and then incorporate them more easily. I wonder if this laptop has internet access. No, it doesn't. Okay, so I was going to click and kind of show you what the site looks like, but we'll do that later. So memory security. Here's one where if you have if you have sensitive information, so I'm not saying store a password in here, but it's the idea that the RAM is also a place where the forensics folks or a bad actor can actually take a snapshot of your RAM of your app, and then they can peruse it using strings or whatever to find sensitive information. Like, let's say patient health information. Let's say you had an app that stored your patient health information, including your name, social security number, kind of critical medical records. You have that stored using encrypted core data inside of a SQLite file that's encrypted, but you pull it up and display it to the user. That time that it's in transit or in memory, perhaps you want to store some of that sensitive information encrypted, so that the only time it's in the clear is at the stack level versus at the heap level. So that makes it harder for that snapshot to take place. So here's this was a little bit of a challenge because of ARC on Objective-C and kind of the way it manages memory and whatnot. So anyways, this is a really interesting anti-tamper technique. Forced inlining is a recent one we just added up there a few weeks ago, and the idea is that inlining code from somewhat of a code reuse perspective is not a good thing, right? You don't want to make the whole point of a compiler is to try to make your executable as concise as possible, but inlining is actually a great way from a security perspective to kind of place information in multiple places throughout the code and to actually truly duplicate it. And so we actually have a tutorial and some techniques up there on how to do it with Objective-C. And again, this is challenging because there's a lot to it that one has to do, and there's several optimization settings one has to figure out. So we have all this up on GitHub to see, and I'm going to drill down into that in a minute in another slide or two. So available today on GitHub, all these different controls, we have 8 of them up there: app password, passcode check, that list. And then we also have taken a look at Remail, and it's an application that Google purchased a few years ago. It's open source. I'll talk more about that in a minute. We also have some recent MDM remote control research. Stuff that we're working on now is we're wrapping up our secure MDM remote control research. We're looking at encrypted code modules. And that's the idea that if you have an app that is on the device, and it's susceptible to a bad actor if they have a hold of your iPad. The bad actor could take the app, pull it onto their laptop, and run IDA Pro on this and reverse the app back to C code, then take a look at all your algorithms and figure out what you're doing. So what we're doing with encrypted code modules is we'd like the developer to identify critical areas of code, maybe one that does a lot of your security work, and actually place that into a dynamic library, and then we'll encrypt the dynamic library so that when the app is now at rest, not being run, there could be portions of it that are just this encrypted blob. So if a bad actor grabbed the code, pulled it back to their laptop, ran IDA Pro on it, they'd decompile the fact that and could see a bunch of the way the UI is run. But when they want to look at particular security areas, that would be encrypted. And so the question is our research is going to look into how much of the app can we encrypt. Now, obviously, anytime we talk dynamic libraries, this can't go up on the App Store. Again, our focus is really that enterprise customer that is building these apps for their particular business, and they're using solutions where they have custom app stores. So in the future, we want to look at encrypted RAM disk, kind of having a way in memory to store sensitive information, kind of that's transient. Dynamic app bundling, a fancy way to say, basically take iMAS, bundle it as a container, and try to add it on the fly, like some commercial products. But this would be an open source solution, so one could, enjoy and look at all the details of how it's done and do your own solution if you'd like. And then off-device trust, we like to experiment with the Lightning connector and perhaps the whole notion where you've seen folks. I don't know if folks have been to Black Hat this last summer, but they had it was a great talk where these folks actually connected a USB charger to an iPad, exploited the USB interface, and did all kinds of stuff, like actually taking an app, pulling it back to their little their little charger, and basically wrapped the Facebook app in this little Trojan app, and then pushed it all back. So when you ran Facebook first, their app ran, which was recording all the keystrokes that you were typing, and then Facebook popped up, so the user wasn't susceptible, didn't know what was happening at all. Anyways, we're going to look into different ways to how from an app perspective, one can make use of that interface, if possible. So let's look at some just technical details of what we're doing with security check. So the jailbreak and debug attach detection, we're doing two interesting things. Most of the books that I described before, they actually talk about, basically take syscontrol and make a call to syscontrol and have it check to see if the process flag has been set to debuggable. That typically can be found by the forensics sleuth that's looking through your code. Here we actually we go down under the covers. We're making actually direct assembly calls below that to read the process flag, and so that's a lot harder to find. And can you imagine if you take that function and you inline that many different places all over your code? So now all of a sudden you have this check that in the past a forensics person could just look for your check and then what you're doing, like maybe you're exiting or whatever, and then just null out the exit call. Here, it'd be much harder to find that. We're also then bundling that in a lightweight thread, so that's a thread that's part of the app. And so now all of a sudden you have these checks that are running when users do things, but then in the background we have these threads that can also be running jailbreak and debug detection. So it makes it, obviously the goal of security is that you'll never get to that 100%, but what we're trying to do is slow the attacker, make them work harder, so that eventually they can get caught or they get frustrated and move on. So forced inlining, like I said, this is a recent security control we put up on GitHub. And so the notion, what you're seeing on the left is a normal execution where you have a check function, and then you run some sensitive code, you check it again, you run some more sensitive code, and check it again. And when the compiler runs, it's really just going to make a call back to this single copy. And in other words, the compiler is going to optimize out all those different functions into this one, so that the bad guy simply just has to say, oh geez, I see that return, I'll just always return false. So it's a simple way to get around that. One function, you can compromise it all. So if you actually forced inline your code, you now have these functions and you have 3 different copies of that same code, and the attacker would have to find all 3 of those and return false. So if one kind of zoomed out on the left, you can see that it's kind of there's a small haystack with one needle. The attacker zooms in on that, makes that one change. 1 patch is needed of the 232 instructions. Here's a look at the code after we've enforced inlining, and here you have 530 instructions, a large haystack, multiple needles. They're not going to be able to find all those, or if they do, it's going to take them a while. So in other words, again, we're just trying to exploit the time, increase the time to make it harder to find these. Switching gears to mobile device management research. So we actually have we've taken and we've deployed an open source MDM server. We forked it from the Intrepidus group. I don't know if folks are familiar with them, but the Intrepidus group has actually built an MDM server. It's open source. We've taken it and actually put up a nice set of tutorials to kind of follow to get you, because there's a lot to do with the certs and getting them all qualified. So what's nice is once we have this open source server available, we're now able to kind of take a look at the process on how this works. We want to try to find the limitations of the MDM spec. We want to understand and test the low-level commands themselves. We ultimately want to try to find out, can we use the MDM interface to do some sort of a single sign-on app? Now, I know iOS 7 is starting to provide that, but here's an open source technique that we're going to try to provide. We want to actually have some sort of way to do a remote app lock, a remote app password reset, and perhaps even a remote jailbreak reporting technique. So not that we're trying to duplicate what these commercial MDM vendors are doing, but we want to make an open source solution available to developers and small companies or even large companies that want to try to have a little more control over how this stuff works and basically be able to add customizations to make it even more secure. Because, I mean, if one has a commercial solution and one takes that to a third party, I should say a third party auditor, the audit comes back and it says, well, all these things have to change. You then go to the commercial solution and say, hey, can you make these changes? And they say, sure, get in line. Here you have a little more control of your destiny. So anyways, those are some of the possibilities we're looking at. So like I talked about with Remail, this is a free and open source project that Google acquired in 2010. It's essentially an email client for iOS. It's kind of cool because it has a very fast way to do search. Here's the front interface for it. If you actually open it up, and it's got a huge search button. So it's kind of a nice way to go in and find emails. But it's pretty decent for actually email itself. It doesn't have a calendar or tasks or to-do lists or anything, just straight email. So we were noticing in the project site to-do list that, quote-unquote, security was needed. So we actually took the app and we wrapped it with iMAS. So exactly what we did is we put a password front end on that, basically used the security control app password. We brought in data at rest. They weren't using encrypted core data. They were going straight to SQL Cipher. So we just added, I should say SQLite. So we just added SQL Cipher on top of that. For the runtime, we actually added memory security where we're protecting sensitive information like the user's email and password, email address and password. We added in the jailbreak and debugger detection. We've put in the OpenSSL crypto, and we're also using the iMAS keychain. And so our goal here is this is going to be kind of our test app through this year, and we want to keep adding more of our security controls. We're going to add in the inline function shortly. And in another few quarters, we want to take this to, we actually want to hire a third-party auditor, have them vet it, and tell us different areas that need improvement. So just a little bit about iMAS outreach. We are up on the OWASP site under the mobile site area. We have a project page. We're listed under the mobile tools section, iMAS. We have a iMAS GitHub page itself, and then if one gets to this page, you can click on each particular one, and it'll take you into the GitHub site itself. Here's an actual look at, this is the GitHub repo, kind of doctored up to fit onto a slide. But essentially, you're seeing the 8 controls that are out there, all listed in a row, and you can see the various stars and forks that are there. And like I said, it's just right now, if one considers this an app container, app containers are usually just a single library that you grab and make use of. This is more of a la carte kind of thing. You pick what you need depending on your security requirements. A little more about GitHub. So part of our research, we have to justify, why are we researching in, what is our return on investment, what is, my company's return on investment, how will this help our sponsors? And so the big question we get is, well, geez, if you open source this, how do we know that you're having impact? And so that's a good question. And so what we did is we actually found this site called GitHalytics, and they allow you to put a small, essentially inside your About pages on GitHub, you can put a small link in there that when the About page is loaded on GitHub, it'll actually go to this GitHalytics site, which then will send the fact that there was a hit to Google Analytics. So it allows us to at least get pure hit counts of how many times our page has been opened. And so that's been helpful because as I go and ask for more dollars for research, I can actually talk these numbers. I can say, well, geez, we've had a lot of growth this month. So let's talk about that. And so this went basically live March 4th. For the last 8 months, we've had over 25,000 unique visitors. 30,000 page views. Most visits from 108 countries around the world, mostly U.S., Germany, India, UK, Canada, and China. So for us, for that 8 months, my research sponsors have looked at that and said, "This is great. I mean, they have other GitHub projects, they have other open source projects, and they're not getting this kind of these kind of numbers. So it's more of just a mystery. It's just throw it over the wall and then keep doing your research. Here, we're actually trying to interact and keep the community alive. So with these numbers, we can actually continue to say, hey, geez, what else can we do to help and increase our community? If you look at the big thing is some really neat numbers are the star count. This is what GitHub provides, is the star notion. So what the stars mean is there's 307 of them. So if you look at all 8 projects, 307 developers on GitHub have started to say they're interested in it. And there's 61 forks. So approximately 61 developers had said, hey, this is interesting to me. I'm going to fork this and make a copy of the code. Perhaps I'm going to make changes to it. So that for us is pretty decent in 8 months. So we're trying to get some sort of a value claim here. And visits and use is moderate and steadily increasing. And so this has been pretty useful. So I encourage folks, if you have a GitHub site out there and you're trying to elicit some sort of gauge as to usage, check it out. So we have an iMAS video. It's a little 3.5-minute video, and it's great for someone that sends me an email, says, hey, I'm interested in iMAS. We have public released this. It's up on the GitHub site. And it's a quick little, high level to show a general or a VP or a CIO or something like that. We were written up in Computer World back in April of last year. So in the future, what else are we looking at? I talked about this a little bit. Essentially, we want to continue researching our security controls, those that we haven't finished in FY13. We want to actually continue that MDM remote control interface. And so one particular area, to expand upon that a little bit, in that MDM control area, we've actually found that if you have if your app is not managed by the MDM server, then then you really can't do much with it from an MDM perspective. But it's kind of somewhat of a pain to take all these apps and make them managed. So what we thought is, why don't we have one app and have it the single sign-on app, say, and make that the managed app. And so, so in that app we could put jailbreak detection, we could put the app password, essentially make it your enterprise single sign-on solution. So, and that's managed. So that gets downloaded through the MDM interface. And so from there, when a user would log into that, we would do some sort of a technique to pass the login information or key over to another app that is part of your enterprise solution. And once that app is launched, we could, again, present, the user would be able to log in that way. So we're kind of researching. So the idea is that if the MDM, if that sign-on app was remotely deleted using the MDM interface, one could basically block access to these other apps by just removing that one app. So it's something that, it's hard to describe, but it's something that we're looking at. It has some interesting promise. I talked pretty much about most of this, so I'll just move to the next slide. So what's our end game? Where are we trying to go? We want to get to this notion of secure complete, and that's where we've, all these applicable OWASP mobile top 10 and the 12 of the 24 mobile threats are mitigated to a level that we're satisfied with. It'd be great if the open source site itself was self-sustaining. That is, more and more folks who are contributing to doing pull requests and all that. We're seeing that with encrypted core data, but the other controls are slowly coming along. We'd like to be able to transition this research to our sponsors, that's the government or perhaps even a commercial entity. So I have a demonstration that I'm going to attempt. I do have a hardware problem on this laptop for some reason with this connection mechanism that occasionally the screen will just go black, and so we'll just go until the screen goes black. See what happens. All right, so drum roll. All right. So far so good. So this is what you're seeing is the app passcode security control. We've actually put it together in a small little demonstration app. And so what I'll do is just kind of walk through what you can do. So we'll set a passcode. Try not to fat finger it. And if you notice, there's a forget button up there. That's something that I've seen some apps that, some of these type of controls where it's just a simple passcode and it doesn't think about that forget password. So usually if the user does forget it, they have to delete the whole app and reinstall it. So here we have a forget. And what that means is we also provide an alternate key, which is these questions. So I'll just make the questions and answers real easy. And so now we're into this test app, and you can see that once you're in the app, one can then change views and get into the real the app itself. Here we have, we show the logout button, complete with, pop up. Are you sure? So they log out, and then we'll rerun it again. And again, remember the whole idea is that we want to try to make it easier for the developers to incorporate these. So, let's log in again. Actually, let's go with the forget technique. And so what's the question to answer A? It was B, and the answer C is D. And they say, hey, success, you've entered the right one, set a new passcode. And then you're back into the app. Now I know if you work for an enterprise company and they have an IT group, the IT group's going to love the fact that it comes with a password reset because IT helplines hate getting calls about password resets. So again, this is another way to increase usage of mobile applications just to make it easier and less difficult for IT groups. So then there's also a reset passcode button in there where one can again answer the questions and great, and then reset it properly. Now, if along the way, this actually has the various controls for iMAS in there. So if things like if one tries to try to hack into this in a way, like just by doing the forget password, and you type in the wrong things, questions don't match, and it just dies. It doesn't let the user rerun it over and over again. It makes it a little harder. So just to give you to do a contrast of that, here is another free open source passcode app that's out there. It's out on GitHub. And essentially, what's nice about this, it has an excellent user interface, real simple to use. You can set it. It looks very similar to the old login screens of iOS 6 and 5. You can enter it, change it, things like that. But if you actually look in the code of what's going on here, and I don't know if you're going to be able to see this, but yeah, you probably not. But in the code itself, they basically have a single password. They have a single password method that they're storing this. Here it is right here, this passcode. Yeah, you can't really see it. Anyways, it's real simple, and if a developer grabbed and took this, the whole back end isn't there. Looking at security code on the screen is hard to see, so I just encourage folks to head over to our site and check out iMAS. I have a little more time, so I'm going to jump to a couple more slides. We actually did a third-party audit of. Actually, let me talk about HReader first. So HReader is another MITRE internal research prototype in the healthcare space. So this is basically an iPad app that allows one to. It's basically an open source, patient-focused app, and so you can actually put health. It's a health viewer. So one can put your own medical records in there, your family's medical records. So you can imagine this information needs to be protected. So we were asked to secure this with iMAS. Essentially, they asked us to do an audit. They gave us the requirements that HReader is mostly offline. The application security is basic, needs to be bolstered. What was interesting is that the developers on the project said, hey, we're using data protection, and we have a passcode. It's secure. So we actually went in there and did a forensics test on this. We had synthetic patient data, not real data. We actually used a DISA, this is a Defense Department kind of application STIG. At the time, the mobile application SRGs weren't out yet, so we used a STIG, basically a big security requirements checklist to make an assessment of the app initially, and then when we did our audits, and then they added more security, and we did more audits. So essentially, in this STIG, there was 255 total criteria. We found that there were 78 were applicable to HReader as a mobile prototype. Our initial assessment was that only 27 passed, or 16% passed. So The developers thought it was secure because they had data protection, but under the covers, using all of the different forensic tools, we were able to easily bypass and find this synthetic patient data, which was a data compromise. So after several audits, we got it down to 72 criteria passed and only 8 failed. So in a way, we've increased the security of the application 5 times. And that's just, using the STIG requirements and then, of course, the iMAS security controls. So going back to, so that was one way to kind of vet out, what are we doing on iMAS and is it effective? Another way was we actually brought in a third-party company via forensics, and they actually took HReader that was bolstered with iMAS, and we had them run all their tests on it. What was interesting is that, like I said, network wasn't our focus, so they did find a couple of network problems. But they also found the SQLite database key was in memory, and that was a slight on our part, so we fixed that. And we had at the time, we didn't have the right technique to store that key and make that more secure. Now we do. So we've mitigated that. Our jailbreak detection and counter debugging worked really well. As a matter of fact, their claim was they were going to spend 2 or 3 days on this. At the end of day 2, they sent us an email that said, hey, could you send us another copy of the app without the jailbreak debugger detection on, because we were having trouble getting by that. So that was like, all right. And then it turns out we got an email 4 hours later that they managed to find it and patch over it. So there we slowed the attacker by possibly 3 days, which was pretty cool. So after we kind of mitigated this, we concluded that we passed the test. But the point is that these controls that are up on GitHub have been vetted by a third party, and we plan to do it again. So this is, again, saving labor and effort for enterprises that want to get into this space. iMAS does that for you. So one last thing I wanted to show you before I end is that on the site itself, I encourage you to check out each particular control, because we actually get into the CWEs of particular weaknesses that are out there. So if one has a security architect come to them and say, well, geez, you got to make sure we cover these CWEs, we meet these requirements, and the developer says, huh? Go into the security controls, check it out. They actually list the particular CWEs that this covers. We actually list the SRG and STIG requirements that are in there that we cover as well. So here it's a nice mapping of, hey, my security guy said I got to do these things. This control does those things. I'm going to use this control, and then so it's a nice way for a dev team to say, hey, we've covered these security requirements, so that ultimately you're probably going to get your app third-party vetted again, which is fine. And what's nice is you should be able to say to this third party, hey, we've done all these things, and I think with iMAS you'll very likely get a passing grade. Any questions? Well, thank you everyone for attending. I appreciate your time.